So let's look at this question. The number of real roots of the equation 2 cos x x plus 1 equals to 2x plus 2 raised to minus x is equals to. Now instead of solving this entire equation in one go, because it will get really difficult, because on one side we have got exponential, which is 2 raised to x and 2 raised to minus x, and on one side we got trigonometry. So instead of doing that, what we do is basically we see if there is a commonality or if there is a range for these four functions which we can utilize for this equality to work. So on the left hand side, let's say cos x function. We all know cos x as a trigonometric function has a limitation of 1 and minus 1 for the output. The cos x function looks something like this, right? This looks something like this. Cos x function looks something like this, and the maximum value that cos of any x of any value which will be in radians is maximum or minimum 1 and minus 1, right? That is the range for this function. If I multiply by 2, then I'll multiply all of the values with 2, right? It's greater than minus 2 till 2. Fair enough. So this is my cos function. For this function, now we have a basic understanding that 1 x plus 1 by x, in which x is 2 raised to x. So just denoting, is always greater than equal to 2. That is the minimum value that it can get, right? This is applicable to 2 raised to x multiplied by 2 raised to minus x as well. Now, if you don't remember this, how to arrive at this, I'll give you. We all know that AP is greater than equal to GP. Now, AP of 2 raised to x plus 2 raised to minus x, sorry, AM, mean, geometric mean is greater than arithmetic mean is greater than geometric mean. So, arithmetic mean of 2 raised to x and 2 raised to minus x will be both of them added by 2, and square root of them will be their geometric mean, to 2 raised to x into 2 raised to minus x. Now this will go to 1, this will become, they will cancel each other out and they will become 1. Square root of 1 is 1. 2 goes on the right hand side, it becomes 2. So 2 raised to x plus 2 raised to minus x have the least value 2. They cannot go beyond 2. Now you can see we have one function, this, which is less than 2. So left hand side is less than equal to 2. Right hand side is greater than equal to 2. That means that both of them will equate at 2. Fair enough. They will both equate at 2. Now let's look at LHS. पहले देखते हैं कि RHS क्या होता है. So RHS is 2 raised to x plus 2 raised to minus x is equals to 2, right? What value will they both be to? X equal to 0, obviously, because they both will become 1 plus 1 equal to 2. So for x equal to 0, they will be 2. For any other value, they will not be 0. They will not be 0. The power will not be 0. And if the power is not 0, let's say power is 1 plus 2. So this becomes 5 by 2. This will not be 2. It will be increasing by 2. So in that case, the only solution for RHS is x equal to 0. Let's see if RHS x equal to 0 works for LHS. For LHS, we have 2 cos of x comma x multiplied by x plus 1. Now when we put x equal to 0 in this, we get 2 into cos of 0 multiplied by 0 plus 1, which in turn becomes 0. Cos of 0 is 1 and we get 2, right? So that is also a solution for this. Hence, at this point of time, only one value is there which satisfies this equation. So the number of real roots for this equation is C1. I hope you understood the method of this. When you cannot solve the equation in its entirety, you have to look at the range. I'll see you in the next one.